All right, so in this lesson, we're going to talk about how to find limits algebraically. So this time, we're just going to talk about how to find them when our limit is as x is approaching a number. So it has to be approaching a number like 5 or -3. We're not going to talk about when it approaches positive or negative infinity yet. Okay, so we're talking about just these types of limits, and the first thing we do is plug in the number they give us. So if it says plug in 5, or as x approaches 5, we plug 5 into our function. Okay, if we get a number back, beautiful. That's our limit, we're done. However, if I get a number over 0, something that's undefined, well, that depends. Graphically, that means we have a vertical asymptote there. And if we're talking about a two-sided limit, the limit does not exist. If we're talking about a one-sided limit, then we want to plug in a number that's very close on the given side. So for instance, if you were doing as x approaches 2 from the positive side, you'd pick something a little bit bigger than 2, like 2.1, and then you would plug in 2.1, get your answer, and whether it's positive or negative will tell you if the answer is positive or negative infinity. Okay, if it's a two-sided limit though, we'd say it doesn't exist. For a one-sided limit though, we would either put positive or negative infinity. And the way you tell, again, is to plug in a number very close on the correct side. So if you're doing positive 2, plug in 2.1. If you're doing as x approaches 2 from the negative side, plug in 1.9, right? So that would be just left of 2 on the number line. Anyway, our last case is what happens if I get 0 over 0. This is called indeterminate form. And this one is one of the more complicated ones. Okay, what we need to do is manipulate our equation though. So sometimes that means factoring and canceling out common factors, or we might need to use conjugates, which we'll talk about again. So remember, conjugates are like a plus b and a minus b would be considered conjugates of one another. But conjugates can help us cancel some stuff out. We then simplify our expression and then plug back in, and hopefully we get a number that time. Okay, so this is kind of the flowchart we're going to use. We're not going to do this stuff yet. All right, let's try some examples here. So here, it's the limit as x approaches -1. Now again, we're not talking about 1 from the negative sign. That negative sign would go after 1 if that's what we meant. This is just as x approaches -1. This is a two-sided limit. And the first thing we do is substitute in the value they gave us. Let's plug in -1 for x and see if we get a nice answer back. Well, -1 squared is 1. 1 plus 2 is 3. And 3 divided by -1 is -3. And hey, that's it. That's our limit. We got a nice number back. We're done. The limit as x approaches -1 is -3. Okay, that's the easiest case. When you plug in, you get an answer back, the easiest possible case. Okay, our next two are going to be a little more difficult, as you see, as we try to plug in first. Okay, so here we're approaching 3, and again, it doesn't say that plus or minus afterwards means it is a two-sided limit. So if I plug in 3, hopefully we can see right away 3 squared minus 9, we're going to get 0 over 0, right? 9 minus 9. So we have that indeterminate form, which means we need to try to factor and cancel out factors, or maybe use conjugates. But looking at this bottom, hopefully you guys recognize from Algebra 2, this is your difference of squares. So what we're going to do is factor. Now I can't do much with the top, but I can think of it as its own factor. And the bottom is the difference of squares, x plus 3 times x minus 3. And we'll note that we can cancel out the common factor x minus 3. So we get 1 over x plus 3, and now we can re-substitute our value. So now we're going to plug in 3, right? We want to know what our limit is approaching as we get closer and closer to 3. So we plug in, and it turns out it's getting closer and closer to 1/6. Our limit is 1/6. Okay, so again, if you get this 0 over 0 form, and one thing that's important is not to write equal. Okay, apparently on the AP test, they will take points off for you if you write equals here. It does not equal 0, 0. It approaches 0 over 0, which means it's indeterminate form. So don't put an equal sign. I guess that's like an automatic point deduction on that question if you do it. So just say approaches. You wouldn't say equal until you got to a final answer. And even then, you can see I didn't even write equal. All right, let's try our next one here. Now note again, this is a two-sided limit as x approaches 0, and we're going to start by substituting in. Well, if I do, I can already tell the bottom 0, so that's not good. And the square root of 1 would give me 1, and so 1 minus 1 over 0 is 0 over 0. We approach 0 over 0 again. Okay, well, this time I can't factor, right? But what we can do is use conjugates. So you guys might remember like complex conjugates, a plus bi and a minus bi were conjugates, or a plus b and a minus b were conjugates. And the nice thing is if you multiply something times its conjugate, you get to cancel some stuff out, like some middle terms. And in fact, you can use that to cancel radicals out, which is pretty nice. So the conjugate of the top here, you can think of this as kind of a minus b, where that's a and that's b. Its conjugate is going to be a plus b. So here is the original, okay, minus 1 over x. And we're going to multiply it, top and bottom, by the conjugate, the square root of x plus 1 plus 1, right? The only difference between conjugates is the sign between them. And so we need to multiply the bottom by the same value. We're essentially multiplying by kind of a fancy 1, right? Something divided by itself. Okay, now the reason this is going to work is because when you multiply something by the conjugate, this root times this root is this root squared. I think we're kind of foiling these out, in other words. Radical times that radical gives me x plus 1. Then we get this radical times positive 1, and this radical times negative 1. And in fact, kind of the middle terms, when you multiply conjugates, would cancel out. So I'm not even going to write the middle terms because they've canceled out. And so think about our last step in our FOIL, negative 1 times 1 is minus 1. Okay, in the bottom, we're really just going to kind of put these guys together and just write that as x times the square root of x plus 1 in parentheses there. Now note, up top, hey, we got a plus 1 and minus 1. Those cancel. So we get x over x times our square root of x plus 1. And now you might see, finally, we get to cancel these x's. All of that work was to really be able to cancel out these x's. So we end up with 1 over our radical, and we can finally plug back in. So what do we need to plug in? 0. And so we get 1 over the square root of 0 plus 1, or 1. Of course, the square root of 1 is 1. And we end up with 1/2. The limit here equals 1/2. Now again, when it goes to 0, 0, don't write equals, write like approaches, use that arrow notation so you're not docked points when you hopefully eventually take your AP test. Okay, so here are our next 3 examples, and note that they are pretty similar, okay, but note some differences here. Number 4 is the limit as x approaches 2. This is a two-sided limit. And hopefully you can see the first thing again we want to try to do is plug in our value. And sure enough, we get 50 over 0. That's undefined. Okay, when you get a number over 0, for a two-sided limit, what that means is that you might remember this from rational functions, this is a vertical asymptote. And when you have vertical asymptotes, typically your graph usually does something like that, curves away from it, or even if they both go to positive or negative infinity. For a two-sided limit like this, we would say the limit does not exist. And that's it, the limit doesn't exist. For a two-sided limit, does not exist. Okay, however, for a one-sided limit, and you note here that we are approaching 2 from the left, to the left of positive 2 on our number line. So we already saw that if I plug in 2, we're going to get 50 over 0. So what we want to do after we've tried plugging in 2, and again getting that same result, is we want to plug in a value just left of 2, like say 1.9. Okay, and again, you only need to do this for a one-sided limit. But if we do 1.9 minus 2, we get 50 over negative 0.1. And what we're really looking for is the sign of this answer. Is it positive or negative? And we have a positive divided by a negative. My answer is negative. And what that means is from the left-hand side, this vertical asymptote is actually going down towards negative infinity. And that's what we write as our answer. For the one-sided limit, it goes to negative infinity. Okay, and for the two-sided limit, we'd say it doesn't exist. For the one-sided limit, it goes to negative infinity. Well, what happens if we approach the same value, though, from the right? Okay, so let's approach this one from the right. So we already know by plugging in, we'd get 50 over 0. And again, we know we're approaching it from the right because it's got that plus sign after our 2. So we're going to plug in a value a little bit bigger than 2, or to the right of 2 on the number line. That gives me 50 over 0.1. And again, we're looking for the sign of this answer if it's a one-sided limit. Is it positive or negative? Of course, a positive divided by a positive is positive. What that means is this graph from the right-hand side, if you're approaching 2 from the right-hand side, has a vertical asymptote. And it's actually shooting up to positive infinity from the right-hand side, and on the left-hand side, it's shooting downwards. So the two-sided limit does not exist because they're going towards different values. From the left, it's going towards negative infinity, and on the right, it's going towards positive infinity. So note that these all have different answers, right? The two-sided limit does not exist. Approaching it from the left goes to negative infinity, and from the right, positive infinity. So when you get this form, a number over 0, we need to ask ourselves, is it a two-sided limit? Is it from the left or from the right? And if it's from the left or right, pick a value just to the left of your number or just to the right of your number. And we're just interested in the sign, positive or negative. Okay, our last section here has to do with some special trig limits. And these ones are a little tougher to explain, but if you graph them in something like Desmos and look at what's happening at the graph, you'll see that these values are true. But what has to match here for us to be able to use these is the x inside of sign here, inside of the argument, has to match the denominator. So if that said sine of, say, 2x over 2x, and we were doing the limit as x approaches 0, and that's important, we only use these when x is approaching 0, then this would also equal 1, because the argument and denominator match. Okay, and we can kind of manipulate our equations to make that happen, which we'll talk about. And for the same thing for cosine, again, our limit will be x approaching infinity, or sorry, 0, not infinity. But what's inside of cosine, the argument, has to match the denominator. Okay, so here's what we can do. So if I look at our first one, we do have that case as x goes to infinity, or sorry, to 0, I said it again. But the inside our argument does not match the denominator. So what we can do is this. We can multiply our fraction by anything we want. Well, I want the bottom to look like the argument in here. Let's multiply the bottom by 5, which means I'll need to multiply the top by 5, right? So that we're multiplying by 1. So this would give me, and here the limit notation doesn't go away. You're supposed to keep this limit notation. Sine of 5x, and at the bottom, x times 5 is the same as 5x. And note, now that 5 we kind of brought over here in front of our x, but we still have this times 5 here, right? From the numerator, like we haven't done anything with this. So essentially, we get this limit equals 1, right? Because the argument is matching the denominator. And so this part of our limit equals 1 for sine, and we're multiplying it by 5. So we essentially get 1 times 5, or 5. The limit there is 5. Okay, this is a little tricky, so let's try one more here as our last example. Now note again, so this looks more like our second one. Limit as x goes to 0, 1 minus cosine of 3x. And again, in order for this to work, sorry about that, in order for this to work, the argument has to match the denominator. So just like before, if this is 3x, we want the denominator to match it and be 3x. Let's multiply the bottom by 3, which means we need to multiply the top times 3. Okay, so now we get the limit as x approaches 0. This 3 kind of comes down here, is going to become 3x. So we get 1 minus the cosine of 3x over 3x. And once again, times our 3 over 1. Well, we know this part of our limit ends up equaling 0. So we actually get 0 times 3, which is just 0. But you need to kind of show those steps to get full points when you eventually take the AP test. All right, that's it. I know these last ones were a little weird. They're just ones you kind of have to memorize the form of, so definitely have those in your notes. We're going to go over lots more different types of questions, one-sided limits, two-sided limits, the indeterminate form, like the 0 over 0, 0 over a number. And the more you practice them, the better you'll feel. But definitely have this flow chart, at least the left side. Obviously, we haven't talked about the right side yet. And then make sure you ask questions and are active in class, because this is really important to start to learn the basics of calculus.